Welcome all. Today we'll be looking at laws of exponents, scientific and engineering notation. Well, first of all, let's be reminded what an exponent is. Let's look at this case. If I have 2 times 2 times 2 times 2 times 2, I can see that I'm multiplying 2 by itself 1, 2, 3, 4, 5 times. So this can be written as 2 to the exponent 5. Okay, so the 2 tells me that I'm multiplying this number 2 by itself 5 times. Now, the 2 to the 5 is actually called a power. 2, the number I'm multiplying by itself, is called the base. And the 5, which is how many times I'm multiplying the base 2 by itself, is called the exponent. So, in general, if I have a to the n, it simply means I'm multiplying the base a by itself how many times? N times. So that's simply what an exponent is. So base raised to a exponent to an exponent is the same as a power. Now, if I wanted to find, say, 3 squared, which is obviously a power, I could use a button which says x squared on my calculator. But if I wanted to find, say, 3 to the 5th, there are a few things I could use. I could use a caret button, or something looking like an A to the B button, or something similar. And we're going to be looking at that just now. So now let us solve these two problems. I'll be using a Sharp ELW 535 calculator, which is there. So if we look, we see that there is an x squared button right here, and the y to the x is right here. So let us first find 3.25 squared. So we enter 3.25, then the x squared button, then enter. I'm getting a mixed fraction. I press change, which is just before data here. Now I get an improper fraction. I do it once again. I get 10.5625. Okay, now in the second problem, we have to be very careful. For the outer brackets, we're going to have like outer brackets there. Then for the numerator and denominator, we need to have brackets also. So let's look at what we're doing here. We're going to have outer brackets, which is there. Then we're going to need inner brackets for the numerator and denominator. Then on the outside, we're going to put our a to the b and then our 3 to cube the whole thing. So let us see how that is done. So let us enter. Open bracket once, open bracket again, then we're going to have 1.6 minus 3.2. Now that's the numerator, so we close the bracket, then we do our divide by, then we open bracket again for the denominator, then we enter 2.8 plus 4.3, then we have to close brackets twice, then we want to raise that to the exponent 3, so we go y to the x, then 3, then enter, and see we're getting negative 0.011448185. I won't go to as many decimal places, so we write negative 0.011444. Next, we're going to be looking at some laws of exponents. The first law of exponent involves negative exponents. What happens if we have something like x to the negative 1? Well, let's do a more general case. If we have a to the negative n, it just means 1 over a to the positive n. So that's really the most general rule. So if we have a to the negative 1, it just means 1 over x rather to the exponent 1, which is just 1 over x. Let's do another example. If I had 3 to the negative 2, it simply means 1 over 3 to the positive 2. All right? As a matter of fact, more generally, whenever I move a power either from numerator to denominator or vice versa, the sign of the exponent changes. So if I had 2 to the negative 5 here, then it goes up and becomes 2 to the positive 5. And likewise, if I had 2 to the positive 5 here, it could go down and become 2 to the negative 5. Let's do an example right here for you just to demonstrate. If I had something like 3 to the 5th over 2 to the negative 3, and in the numerator I also had 4 to the negative 2. If I wanted to write this as a expression with positive exponents only, well, 3 to the 5th is already positive, so that stays there. This 4 negative 2 is negative exponent, so I move it down, it becomes 4 to the positive 2, and this 2 negative 3 goes up and becomes a 2 to the positive 3. This will be very important later on. With that in mind, this first problem, I'm just going to write it with a positive exponents only. I won't evaluate. It's going to become 1 over 0.789 to the exponent 1, which is the same as 1 over 0.789. Okay, for this one, the negative 4 applies only to the 0.098. So this becomes 3.14 over 0.098 to the exponent 4. Now, C and D, we'll have to use the thing I showed you right here. Okay, so whenever you move a power from either numerator to denominator or vice versa, the sign of the exponent changes. So let's look at this C. So the x is the exponent 1, that stays, but y negative 1 goes in the denominator and becomes y to the positive 1, or just y. Now for this one, a stays as positive exponent 1, b negative 2 goes down as a b squared, c negative 3 goes up as a c to the exponent 3, and the d stays. So we have one law down, we have 6 to go. 0 exponents. Any base to the exponent 0 always works out to be 1. So in case A, you don't have to actually work all this out. It's all in brackets to the exponent 0, so that's 1. Again, we have something in brackets here to the exponent 0, that's 1. Now you have to be careful, don't get caught in this. I'm going to give you an example. So I'm going to say, however, if I had 3 times sine of 30 degrees plus the square root of 10 to the exponent 0. Now this exponent 0 applies only to what's in the bracket. So now this becomes 3 times 1, which is just 3. So we have to be careful of those situations. The next one here is powers. If I have a power raised to an exponent, I simply keep the base and multiply the exponents. Okay, so in this case, a squared is a power which I'm raising to the exponent 3. So I simply keep the base and multiply the exponents. So 2 times 3 gives me a to the exponent 6. Likewise, you can see that this here is just 3 to the exponent negative 1 times 4, which is negative 4, which I can write as a positive exponent 1 over 3 to the exponent positive 4. Now, products. If I have the same base with different exponents and I'm multiplying, I simply keep the base and add the exponents. So that is, when we're multiplying two powers with the same base, we keep the base and add the exponents. So in this case, we have the same base 5, and we're multiplying, so we simply keep the base and add the exponents. So negative 5 plus 2, which is going to be 5 to the negative 3, which we could write as 1 over 5 to the positive 3. All right. Now, B, we can rewrite this as 2 times a cubed times a squared. So the 2 stays. We keep the base a and add the exponents. So it becomes 2a to the exponent 5. Now for this one, we have to be very careful with our housekeeping. 3 is kept by itself. We normally put the numerical value first. Now, what about a? A is to the exponent 1 here, is to the exponent 2 there, so we simply add 1 plus 2 to give us a to the exponent. Well, let me write it down. A to the 1 plus 2. Then we have y. We have y to the exponent 3 there. Then y to the exponent 1. We're multiplying, so we add the exponents. So this now becomes 3a to the exponent 3, and then y to the exponent 4. Next we have what we call a product raised to a power. So the base is now a product xy. So in this case, the exponent applies to both numbers that make up the product. So this becomes xn, yn. Right? So in this case, we have 6a all squared. So we write it as 6 squared, then a squared. Now 6 squared we can simplify to be 36, and then a squared. Our next problem is 0.445 times 0.663 to the exponent 3. So well, first of all, this could be just written as 1 over 0.445 times 0.663 all to the exponent positive 3. You could plug that in your calculator. But we're going to be using the product raised to a power rule here. So this can be written as 0.445 to the exponent negative 3, and then times 0.663 to the exponent negative 3. Now, we could now write this as 1 over 0.445 to the exponent 3 using the negative exponent rule, and then times 0.663 to the exponent 3, which is exactly the same as that. We're on to the last two laws of exponents. When we have two powers with the same, two powers that we are dividing, same base, what we do is that we keep the base and subtract the exponents. Okay? So in this case, we're dividing two powers with the same base x, so we keep the base and subtract the exponents, so this becomes x to the exponent 2. Right? Now in this case, Let's simplify. Well, first of all, we could reduce this fraction. 3 into itself, 1, 3 into 15 goes 5. So we end up with a 5 in the numerator. Now we want positive exponents. So, well, there are actually different ways of looking at this. Let's keep this 5 here. So since we are dividing, we are going to keep the b, the beta. We're subtracting, so we have negative 2 to start, and we're subtracting the 5. So this now actually becomes 5 beta to the negative 7, which we can write as 5 over beta to the 7. Now, what I was alluding to here was that just looking at this, you could see that we have 5 in the numerator, right? And we could actually bring the negative 2 down. It becomes positive 2. So we're going to have beta to the 5 times beta squared, which is the same as 5 over beta to the 5 plus 2, which is 7, which is exactly what we have there. The last rule is that we have a quotient x divided by y raised to an exponent. In this case, the numerator and the denominator are raised to the same exponent. So this is the same as x to the n over y to the n. Okay? So in this case, we have a over b to the negative 2. So that's the same as a negative 2 over b negative 2, which we could now write with positive exponents. The a to the 2 rather, a negative 2 goes down to become a squared, and the b negative 2 goes to the numerator to become b squared. In this case, now we do the same thing, numerator, denominator. Now this 3 is actually 3 to the exponent 1. So I multiply the exponent with the exponent on the outside, so it becomes 3 to the 1 times 2, which is 2. Then y to the 2, 2 is 4. X is to the exponent 1, 1 times 2 is x squared. All right. Now our last example. We have 0.9978 negative 2 to the exponent 3. So I simply multiply the exponents. It becomes 0.9978 to the exponent negative 2 times 3. It's negative 6, which of course I can write as 1 over 0.9978 to the exponent 6. And those are all the rules of exponents. Let's now talk a bit about roots. Now we know that 2 squared is equal to 4. Therefore, we could say that the square root of 4 is 2. Likewise, we know that 3 squared, it's 9. Therefore, we could say that the square root of 9 is 3. I hope you're seeing a pattern. We know that 4 squared is 16. Therefore, the square root of 16 is 4. Now, to find the square root, we use the button on your calculator that looks like this. So we could, for example, enter square root 16 and we will get 4. Let's do that just now. So we write square root of 16 and we indeed get 4. All right? So now let us look at this. So the square root of 64 is 8, since 8 times 8 or 8 squared is 64. So root of 64 is just 8. Right? Now, square root can sometimes be written as an exponent of a half. So to find the root of 64, instead of using this here, we could have entered this in our calculator and we would get also 8. Let's do that. So we could enter 64, enter the y to the x button, and we could enter a half. I'm going to put it in brackets. 1 divided by 2 close bracket, and there we get 8, right? So they are equivalent. Let's look at the cube root. We know that 2 times 2 times 2 is 8, or 2 cubed is 8. Therefore, we could say that the cube root of 8 is 2. We also know that 3 times 3 times 3, or 3 cubed, is 27. Therefore, we could say that the cube root of 27 is 3. We also know that we could write the cube root of 27 as 3 to the 1/3, based on what we just learned. So here are some examples. The cube root of 125 is, so we say, what number do we multiply by itself 3 times to get 125? Well, we know it's going to be 5. Let's do that on the calculator. So we're going to be using a button that actually looks like it's above the y to the x button, and it looks something like this. You see like an N. So the N would be the 3. This would be 3, and you enter the 125 on the inside. So this button is just above. You may have to press Shift to get to this button. So let's do that just now. So what we want then is the cube root of 125. So we go Shift, and we get that. Sorry, let's go again. We have to enter the 3 first. 3, Shift. So now we have cube root. Then we enter 125, and we should get 5. And there it is. Now we could also get that by doing 125 to the 1/3. So we go 125 exponent, then we go, I'm going to put brackets here, 1 divided by 3, and we should also get 5, which we did. We'll just take a minute or two to look at powers of 10. Now, 10 is just a very special base, which we find very useful when we're expressing numbers in scientific and engineering notation. Scientific and engineering notation. So let's just do these few examples here. So 10 to the 1 just means 10 multiplied by itself once, so it's just 10. 10 squared means actually 10 times 10, which is really 100. Notice something here. 2, you have 2 zeros, is 100. So we could see the pattern that 10 cubed is going to be a 1 with 3 zeros. It means 10 multiplied by itself 3 times. 10 to the 4th is just a 1 with 4 zeros. 10 to the negative 1 is 1/10, which is just 0.1. 10 negative 2 is 1 over 100, which is 0.01. You could see the pattern already. Negative 2, there are 2 numbers there ending with 1 and zeros in between. 10 negative 3, we're going to have 3 numbers after the decimal point with a 1 there and 2 zeros. 10 to the negative 4 is going to be 0.000 and 1. So next we're going to see how to write numbers in scientific and engineering notation. Alright, so now we're on to scientific and engineering notation. We'll look at scientific notation first. What is scientific notation? It's a way of writing very large numbers or very small numbers in a concise manner. Now, a large number is just a number which is bigger than 1, and a small number is a number which is less than 1. So looking at this here, that's a large number. You could have a lot more zeros too, which would be very cumbersome to write. So we choose to write it in what we call scientific notation. So this number on the left, written in scientific notation, is this, which is a lot more concise. Now there are some rules that will tell you how to write numbers both large and small in scientific notation. Now, you could read this and try to follow this method. I'm going to show you another way of doing it, which is actually quite easy. So you have two methods, and you choose whichever is more comfortable for you. As I said, a large number is just one which is bigger than 1, and a small number is one which is less than 1. Okay? So here is a large number, 325,000,000. So this is the aim of scientific notation. Your decimal point is right here. You want to move your decimal point in such a place that there is only one number to its left. Okay? So the number to the left has to be either a 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we want to move the decimal point there. So if we move it, it becomes 3.25. Now clearly 3.25 isn't the same as this. What we do, we multiply by a power of 10. Now the number that goes here, how do we get that number? We count how many places we moved the decimal point. So how many places did we move it? We moved it 1, 2, 3, 4, 5, 6, 7, 8 places. So now this becomes 10 to the 8th. That's it. So we have one number to the left of the decimal point, and we have times 10 to the how many places you moved your decimal to get it to be between the 3 and the 2. And that's it for large numbers. Now small numbers. Again, our aim, the decimal point is now right here, and we want it, the decimal point is really here, and we want it to go right there. Alright? So now that would become 1.25 times 10 to some exponent. Alright, so we count how many places we moved it. 1, 2, 3, 4. But now for small numbers we put a negative exponent, so it's negative 4. So again, you could move, for large numbers, we always have positive exponents. For small numbers, which means numbers that are less than 1, we have negative exponents. So now let's just do a few examples here. We have 31.056, which we're going to write in scientific notation. So we move the decimal point there. It becomes 3.1056 times 10. Now it's a large number, so we move it one place, so it just becomes 10 to the exponent 1. Likewise, for this number, the decimal point is here. We want it to go there, so we are moving 1, 2, 3, 4 places, so it becomes 6.3458 times 10. We moved it 4 places, so it becomes 10 to the 4th. Now we have 0.0712. We want the decimal point to be there, so it becomes 7.12 times 10. Now this is a small number, it's less than 1, so it has to be a negative. How many places did we move it? 2 places, so it becomes negative 2. Okay, this one we moved the decimal point there, so we moved it 3 places, so it's going to be a negative 3, so it becomes 4.2 times 10 to the negative 3. Now we could go the other way around. When we are given a number in scientific notation, how do we write it in decimal form? Well, in this case, we simply move the decimal place. Well, we know that this is going to be a large number because we have a positive exponent. So we move the decimal point 2 places to the right to make it bigger, 1, 2. So this becomes 876. For this one, we move, it's a large number because we have positive exponents. So we move the decimal point 5 places to the right, so it becomes 560. So 1, 2, and we need 3 more, 1, 2, 3. So in other words, 1, 2, 3, 4, 5. So it's actually 560000. In this case, it's a small number, so we're moving to the left. So 1, 2, 3, then the decimal point, so it becomes 0.00876. Let's check. The decimal point was here 1, 2, 3 places, so it's indeed 0.00876. And you could see this one, you try this on your own, it's going to be 0.0560. Okay. So now we move on to engineering notation. Just one thing to mention here, that you should consult your calculator manual to see how you do scientific and engineering notation work for this course. I won't be doing it just now because you all have different calculators, so I think you should try to just go through the manual and you will know how to do it. Okay, so now let us do engineering notation. It's similar to scientific notation, but now instead of one restriction, there are now two restrictions. The only restriction for scientific was that the number to the left of the decimal point can be any number between 1 and 9. Okay, but now for engineering, you could have either one, listen carefully, there are two restrictions. One is that there can be either 1, 2, or 3 numbers to the left of your decimal point. And the second one is that the exponent of 10 can be multiples of 3. So it could be 0, plus 3, minus 3, plus 6, minus 6, plus 9, minus 10. You get the point. So these numbers here are all in engineering notation. See, let's check the conditions. There are 2 digits here, there is 1 here, there is 3 there, and there's 3 there. So that's good. That's one of the rules. You could have 1, 2, or 3 digits to the left of the decimal point. The second one is that the exponent of 10 has to be a multiple of 3. Well, this is 3, which is 3 times 1. That's 6, which is 3 times 2. That's negative 9, which is 3 times negative 3. And negative 12, which is negative 4 times 3. In fact, I should have said negative 3 times 3. Maybe that's what I said. Okay, let's do a few examples now. So we have 548000. So we go 1, 2, 3. If we go 3 more, it's going to be 0.5, which is not good. It has to be either 1, 2, or 3 digits. So we have to stop there. So this becomes 548 times 10. We move the decimal place 3 places, so it becomes 10 to the 3. It's a large number. For this, it's a small number. We go 1, 2, 3. Now, if we go 3 more, it's going to, well, we could 4, 5, 6, so it becomes 678 times 10. It's a small number, so we put negative 6. Likewise, here we go 1, 2, 3, 4, 5, 6. So it becomes 678.0 times 10. We move it 6 places, and it's a small number, negative 6. All right, and likewise, this is going to be 72.56 times 10 to the 6. You could see how we got that. This is going to be 450 times 10 negative 3, and this becomes 450 times 10 to the negative 3. Now, if these were measurements, then we would have to take accuracy and precision into consideration. All right? These two examples are asking you to go the other way. You're given numbers in engineering notation. You have to write them in normal notation, ordinary notation. So 10 to the 3 means we're multiplying by 1000. You move the decimal place 3 places to the right because it's to make it a large number. So it goes 1, 2, 3, so it becomes 8559. That's it. Now this is a small number because of the negative 6 here. So we move the decimal place 6 places to the left. So 1, 2, 3, and we need 3 more zeros. So 0.123 736.